Once you've got the web page loaded, this is how you do the problems. There are 4 problems to do, and each problem has several parts. So for this, I'm going to do the last one just as an example. Bromine on the periodic table is right here, and it's in group 7A, also known as group 17. So that's 17 valence electrons. No, it's 7. 7 valence electrons, yes. Fluorine is also here in group 7A, also known as group 17. So that's 7 valence electrons. That's 7 plus 3 times 7. That's going to be a total of 28. 28 valence electrons. Click on submit here. That's correct. I do not need you to take a screenshot right here. I need you to take a screenshot at the end. Now, the next step is to just use single bonds, and the way you do that, you just click in between the atoms there, like that, and then you submit. Next. Next is, by terminal atoms, what they mean is the atoms on the outside, not the central atom. Now, to do that, you cannot just click on the atom, unfortunately. You have to go drag the lone pair over there, and you got to drag them. And notice that the available electrons decrement every time you drag a pair of electrons. So you got to keep on doing this until every outer atom has 8 electrons total. See this F, it has 2, 4, 6, and the bond contains 2, so that's 8. This one, 2, 4, 6, 8. This one, 2, 4, 6, 8. Right? Submit, next. And then you have to put any leftover electrons on the central atom. So 1, 2. Now, this breaks the octet rule. So 2, 4, 6, 8, 10. This central atom has 10 electrons. It breaks the octet rule. So I wouldn't give you a problem like this on the quiz for that breaks the octet rule by having too many electrons. Now I will give you problems that break the octet rule by having too few electrons. For example, hydrogen should only have 2 electrons, not 8, when it's in the molecule. Boron should only have 6 electrons, not 8, when it's in a neutral molecule. But this one I just do for you because it's the only one among the 4 problems here that has this is called the extended octet or the expanded octet. Now, just so you know, if you're curious, elements that are in group 3, I'm sorry, period 3, like row number 3 and below, have the ability to host more than 8 electrons if they are the central atom. And the reason why it has to be period number 3 or row number 3 and below is because anything above row number 3 is too small. As a matter of fact, the first atom, the smallest atom that we observe in nature to actually do this, to actually have more than 8 valence electrons as the central atom in a covalent molecule is phosphorus. So it starts with phosphorus. It's a bit rare with phosphorus. The most common that you'll see is sulfur. So SF6 is a molecule, sulfur hexafluoride. So that's with 12 valence electrons on that central sulfur. But it's not necessary for our class right now, just to let you know that is something that happens out there in the wild world of atoms and molecules. Now, when I submit this, and it says correct, I go to the next question, and then here, if you have more electrons, and therefore you need to make a double bond, this is how you would do it. You would click on somebody to remove a pair of electrons, and then you would click on the bond to make it a double bond. And if you wanted to, if you wanted to do both, if you wanted to click on both atoms that are making the bond to remove the lone pair, that's possible too. Now, with this particular online tool, they have you follow the octet rule first with step 3, but only on the outside atoms. They don't have you do it for the central atom, which is not my favorite way to do things, but it is one way to do things. So for that reason, if you have a molecule not like this one, where everyone needs to follow the octet rule, the central atom, you might get to question 5, step number 5, where the central atom still does not have 8 electrons. And so if that is the case, all you got to do is remove a lone pair from this atom. You don't have to remove anything from here. And then you just add a double bond, and boom, you have 8 electrons here, and 2, 4, 6, 8 electrons on the central atom also. You're going to find that you have to do that for one of these problems. I think it is for example 2. I think it is for example 2. All right, so just try different things and do it until you get it right. Or you can just come back to this video and then review this comment that I had just made to fix your work for example 2. All right, so now what I need you to submit is the following picture. So, sorry about that, that's my dog. So what I need you to submit is this. So you submit this, and then it says correct here. So this is question 5 of 5. It says correct. I need you to take a screenshot of this guy, and I need you to upload that. Do you know what I mean? So I don't mean just this one, but I mean for example 3 of 4, I want to see your question 5 of 5 screenshot that says correct down here. For your example 2 of 4, I want to see your question 5 of 5 screenshot and it says correct down here. For your question 1 of 4, I want to see your question 5 of 5 screenshot and it says correct down here. In other words, I want to see 4 screenshots, and they all say correct down here, and they all say question 5 of 5 up here. If you don't know what I just said, I suggest you rewind this back just a little bit and check that out, because I want to see 4 different molecules. They're all complete and correct Lewis structures. They all say question 5 of 5 over here, but they're different molecules, 4 different molecules, and they all say correct down here. Okay, thank you very much.